Hello and welcome to the assembly video for the Man Cave Puzzles RTV. I'm going to go over in detail how to put the whole thing together, and keep in mind when you're watching the video, this is sort of put together with a few different assemblies. So if you see things that seem a little bit out of place and out of sync, it's because I've moved things around to keep the flow of the video. Everything will be covered in it. So don't fear, just go through it and you'll end up with every bit of the assembly that you need.
So let's talk about chassis for a minute. This one is what a chassis will look like after you've cleaned it up. It takes about an hour to clean it up, but they do work well and they're very strong, like extremely strong. And that is printed on an FDM printer. These three are printed on an SLA printer. Now these are the same thing. This is ABS-like. So this one's okay. It's got some flexibility. You can see a little bit of flex there. And it's reasonably strong. Now this is also ABS-like. And the issue I had with it was that I left it wet when I cured it. And I guess the wetness makes it quite brittle, and I can tell you it was very brittle. I was just trying to see how strong it was, like I did with this one just now, and this is what happened. The other thing that I'm making sure I do is that I paint it so it doesn't cure anymore. And this is just a regular, yeah, a regular resin, and it's not very strong compared to the FDM printer one. Alright, so the first thing you're going to need is a chassis, and when you 3D print a chassis, you can either print it on an SLA printer or an FDM printer. FDM printer, you're going to have to use supports, and there's a lot of supports to remove. Now this has probably been, I don't know, I'm going to say 40 minutes of work. Taking all the supports out, cleaning it up, getting all the little bits out, and these are the tools that I use to do that. Pliers, cutters, a very, very small screwdriver, and a ream bit, a flat bottom ream bit to get this part out. It does a nice job of that. So if you're wondering if you print the chassis with a Bamboo Labs printer, this is what it ends up looking like. This is PLA, and it was printed this side down to the build plate. Not bad. Couple screw holes on the side. I've tried to make it so that there's an exit for those screw holes, although these, yeah, also an exit for these. You can see here, and the idea behind that is then you know when you've tapped far enough. So now let's start putting it back together. We'll start with putting a couple of screws in here. Now one thing that's important when you've taken all this out, you got to make sure you've got some little spaces, like the space that's in there. You got to make sure you got the space for this screw down here taken out. Otherwise you won't be able to put this thing in, the new chassis. It's easier when you've got one that you don't have to do a lot of cleanup on, but if you have to do the cleanup, you know what? It's not the end of the earth. Nice and snug, nice and sturdy. So you got to get this bearing into the seat there. So when you're putting it in, you got to make sure it's all the way in. You're going to have to get this in here and this little bit underneath in here. So it can be a bit of a challenge. And the other thing is sometimes you got to turn the gear to get it in all the way. Am I getting everything in? Let's see. Oh, I think we got it. Wow. That was super quick and relatively painless. What a shocker. And then there's a couple more up top. So they're actually going straight through this frame into this piece. Right, so we do have to move the steering arm over. You take off the 2 screws from the top. Once those screws are out, you take the bearings out of the top, and if it's not a VXL, it's not a bearing, it's a bushing, and you push these in, and as you push them in, you pull out up. Go. Right, same. Take it off. This one's got a spring in it, so be a little careful. There we go. So this is the piece you're changing out. Done the legadine, so this one you can put on this side. Click that in, and then you just put this guy back in. Why you no go in? Because I didn't push it down. There. Done. The servo arm we use, there's a difference between the two. Well, size is one, but the angle is also quite different. So this one goes on this side. There we go. Oops, that was me. There we go. Alright, so that's on there. And we've got a compress tool that's printed. This guy fits into that so that it holds onto the right place. And then we compress and then put this in. And there it goes. That was it. Not that hard when you have the right tool. How's that? And there it is. So it was a little bit of pressure with both hands to get it in, but it went in. And then that is safe and secure. And then put the screws back in, if you can. And this one, we're going to use this linkage. It'll fit on the bottom of this. got to admit, that was the first time I tried that tool. I designed it, and I had no idea how it was going to work, and man, did that make it easy. Alright, now we can put the front end on. But before we do the front end, we have to cut this because it has to fit to where this ends. Alright, so here's a cut and a non-cut one. This is 105 millimeters. I'm going to make this other one 106 millimeters. There was about a millimeter of space in the last one I built, so 105 or 106 millimeters. I marked it with my calipers and I made a scratch around. So I use a pipe cutter. The thing you don't want to do is deform it, and a pipe cutter won't deform it. So you've got two almost the same, and then you got a nice taper on here, so you can probably do this by hand, and you end up with a decent taper. You can sort of see it there, and that was just a couple of twists by hand with a large drill bit. This is probably about a 1/2 inch. And there you go. 106 millimeters this time. Alright, so to put on the front end, you're going to need two 16 millimeter M4 screws and then two of the screws that came with the unit. So the drive shaft goes on here. I'll put on the end I did. There. Got all the burrs off of it. That seems good. So drive shaft goes in, and as you put it in, just make sure you get it onto the other one. There we go. Ah, perfect. Okay. One more thing done. Right, so the motor's all ready. I left everything plugged in, the 3 plugs, and this is my 10.5 turn, the experiment. Be the, I don't like to recommend things without trying them. If you were ever tempted to get one of these knockoff brands, with the fins on them that are have the wrong screws, they don't fit in the RTV. I've got a 32P 10 tooth pinion gear on here, and that's the distance, and you can see when you put it on here, the distance means it's right on the bigger gear. You can figure that one out, I'm sure. Goes in like so, and that way it all fits. If we don't do that, it won't fit properly. Now we could have put the holder with drain holes, and you may ask, why does it have drain holes in like all the corners and everywhere? Well, what sits right here is the cartomizer, and I've had one break, and the goop sort of went everywhere, and it ran down the side of the ESC, and then it was pooled in here. So now I make them with holes in them so that it doesn't pool in there, and it actually runs out so you can clean it. So we'll get this guy in first.
There's 2 holes here that I've already done what to. I've already tapped them. And this can too. You know, you can do a couple of things with this. You could either stick it on the front here. I actually just jam it down here with the filter that I put on. So this is the filter, and that one goes on here. And what that does is it filters a lot of the noise from the ESC out so that the boards that we put in after don't have to deal with that. All right, so there we go. We got that. We'll put the... Oh, actually that gear isn't exactly in the right place. I'm going to move it a tiny bit here. Now to get the spacing right, you use just a regular piece of paper in here. And then jam it onto the paper and tighten it up. But only if you can find the screw. Oh, come on. This is super easy to do. Ha 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 ha. Get rid of. So then you take the paper out. It's beautiful. Feels good. And we can put the cover on. All right, so the next step is putting on, well, let's call it this piece. It's the cover for the motor gears here. And it doesn't quite fit as is. If you want it to fit like this, where it actually seals up more or less in here, you're going to have to cut it down a bit. Otherwise, it looks kind of like this, where you got a gap here and a big gap here. See the 2 gaps? Let's compare the 2. What's the big difference between them? Well, there's been a little bit taken out here, so this part, and a little bit taken out there, this part. The rest of it seems to fit. Oh, and this is gone, this piece here. It's just completely gone, because it doesn't fit in with the way this chassis was made. So, I'm going to make this one fit and put it in. Alright, so let's see, we're cutting this guy off. Do that. Cut this guy off. I mean, if you're afraid of modifying what you've got, this is the wrong project for you. This one I might do with a knife. We gouge this out with a knife. And this one I'm going to gouge out with a knife, although I'll take a little bit out with the cutters here. I think we need more on this. This one seems good. Maybe a little more here. That's not the stock screw. I used a bigger screw. So it's time to install at least one of the boards, the RF board. You don't have to install the receiver at the moment, but you should install the receiver connector. This is an NRF 24L01P+, and I've modified it to make it more reliable. The connector that you do need is the one for that board, and it goes in here. Probably a good idea to put these on before this one. There's two ways you can put this in. You could put it in so it faces down, or you can put it in so it faces up. And I can tell you, you want it so it faces up. And that one goes in there. And then there's the switch from the ESC. That goes here. And look, there's two more spots. I can't imagine what those would be. Steering should be at the front, and the signal is at the top. And it's written right here. There's an S and a SIG. So the signal is the white wire. So we'll put that one here like this. And this is your ESC or motor. And we'll put that one here like that. So now we got all these guys in. That's great. We can have the fun of getting this thing to go into this tiny little space here. This is some of the fun. So it's like a compression fit, and I'm going to tell you, it's not easy to get in there, but it does go in. So I start by putting it in at an angle. I'm going to try and show you. Putting it at an angle that way. If I can, the places where you can push on this board, the big connector is okay to push on, so. Oh, wow. Oh, it's at an angle, that's why. All right, yeah, we'll take that out and we'll start again. So, get it flush. And I don't know if you can see that. Try and get more light in here. What you're trying to do is get the bottom into the little slot that's there. So I'm going to try and do that here. Yep, that's in. Okay, now we got to get the rest of this guy in. Some materials are easier to push out of the way than others. This PLA is being ignorant. And I will use a little screwdriver to pry it up under the board here. Just a tiny bit under the Arduino board. Oh man, I can't. It's hard to show you this stuff. So right under here is where I pried it up a little bit. And we're going to try and push that in. I don't want to do it with something metal. It's, I don't feel like breaking stuff. It's kind of a push. There we go. Okay, that one. Oh, the bottom didn't go in. There, bottom's in, top's in. Man, that is not going anywhere. So now it's in. If you're wondering about this number, that is the serial number that I've programmed into the receiver and the transmitter. And when you get them in the kit, you get a couple of these. And they only talk to their own number. So you can have, well, I mean, you can't have 1,000 of these in the same place because the frequency spectrum won't support it. But you could have a few. This is the master board. It's busy. I'm just going to say it's busy. All right, that one connects here. That's the power to it, and that's why you have that massive filter, because this thing really needs some good power. And we're just going to put it here for now. There's so much stuff to connect to it in the future, and this is the holder for it that we'll put on a little bit later. I guess the one connector we can put on is this one, and I like to get this one. Is it on top or underneath? Yeah, it's underneath the servo, but on top of many other things. And it goes like this. So if you were to plug this one in backwards and have it down, then this one would be going straight onto the motor. And you don't want wires mixing with the motor. So this, here, that's where that fits. All right, we are cooking with gas. Let's get... Now this might have been on already in another video, but I've made so many changes trying to make improvements here. So one of the nice things about this design is from the top, you can see where these screws are. That was a big deal in my original design. You couldn't see the screw, and man, it just makes it a nightmare to try and screw something in when you can't see it. Don't put the bar in yet, because you got to put the rear in first. I made a mistake on this box. I actually drilled the holes too big in the bottom part. I made them M3, so I'm going to put in a nut, and I'm going to sink it in using some heat. So I use a long screw, M3 nut. I'm going to get it a little bit away from the plastic to start heating it up with my soldering iron. Oops. Let me get that back up. I don't want to melt the plastic with the soldering iron. So, start off by heating it up a bit. Come on, you. And then when it's reasonably hot, we're just going to sink it into the plastic and then let it sit for a couple of minutes to cool down before we move it. Otherwise, the nut will just turn in the plastic. So that's probably enough. Let's get it in there. There it is. It's in. We're going to leave it for a minute or two. Let it cool down. And I'll show you what it's like. Oh yeah, I got tons of plastic in there from the top end. There you go. Well, you can push it out this way if you want. There we go. And then I can put the insert in and it'll stay sturdy. So one thing I've noticed with this rear connector, the speaker comes so close to this, I've just taken out all of the stuff that comes with the original. You can see it's pretty empty there. Now on the rear box, I like to use light colored screws for those two screws holding in that support piece. And the only reason is they're easier to find when you're looking for them later. So that one goes in like this. The bar will go in after. You got two M320s that go in here. Now one nice feature that is pretty new, if you ever have a problem and you want to release the back box, like I've actually been able to release these two screws for the shock bar, and then take my shock out, move this up, and then do a whole bunch of work on this thing without taking the sides off. It's a godsend. You know, when you have to take the sides off to do stuff, it makes it very complicated. There's a lot of screws there. So what I'm saying is you don't have to unscrew these two screws. You can undo the two side ones that you can see around the speaker. So if you do have to loosen this off for any reason, you can do it without even removing the speaker that we are going to put in next. The other part that's changed is this is a lot sturdier. My old box would have broken doing this already. The new one, all right, now you don't want to tighten it too tight, but you do want it tight enough so it holds it. The new one is strong enough so that it's not going to break. Speaker, well, I got the screws here for it. Now the wire, you want it to go through this hole right there, because it plugs into the board at the back, and it just pops onto these two like that. there's a little void in the bottom, so make sure you clean out the void after you've printed it. You print it with supports. Oh, this was the old serial number for this one. Actually, I like to put the serial number on the back of the speaker rather than here because it's easier to see. You just pull the box off and you can see the serial number. So wherever I put that, here we go. We can put 3CPO back down here. I also like to put it on the inside of the transmitter. So the two places I put it are here, here, and then on the inside I put it on the battery compartment. So when the shock bar goes in, the two little ones face up in front. And then you just plop that in, center it on there, and then you can put these two screws in through the shock bar. If you're pushing down hard enough on it, that is. There we go. Nice part about this, if you do break the shock bar at some point, I've never broken a back one, I've only ever broken a front one, but it's two screws and then you take the shocks off them and you can replace the shock bar. You don't need to take anything apart after. It's kind of handy. All right, let's just do this. Okay, back end is together. Very nice. The front end, I've already put the servos in. You do have to clip the edge of the servos here in order for it to fit under the shock bar. And I put a little tiny dab of glue on my M2 screws, on the back of the M2 screws. But leave this loose, because these should be really, they should be loose and easy to move. There's also a hole in the front here so you can unscrew the servo arm and move it if you really need to. I haven't had to because we can adjust the doors afterwards. I like all of this stuff to come through the side hole here. Before you put this in, it'd probably be a very good idea to do a couple of things. One, I always mark the right one with an R. If you take this apart later and everything is all jammed in here, you're not going to know which one is right and left. And only mark the right one. The left one's on the inside anyway. The right one is the one that you'll see when you take it apart. So the other thing to do, I think it's a very good idea, turn this on before you put this together, just to see where the doors sit. It's not that you can't move them later. Yeah, I'm not really sure why I insist on that, but I really do think it's a good idea. So there, I'm going to grab a battery. The only two things you're going to need to verify where the servos will be at door closed is, other than what's in here, is a battery, which we will connect, and your switch, which we will connect. And the switch goes right here. Okay, now, those are in the closed position. You can move them if you want, and now would be a decent time to do that. I don't think either of them are outrageous. We could leave it, or we could move them, because there's an adjustment that you can make later on. Generally, I try and make them in between these two on both of them. So I'll adjust them and show you the right spot. So thankfully, we don't have to take the servos out to adjust them. You can actually get the screwdriver in that little hole and unscrew the servo horn. And then pry it off. Now, when it's closed, it should be around here. Yeah, right around there, right around the bottom of that thing. So we can put that screw back in. Thankfully, this one's magnetic. There we go. So now you've got him approximately in the right spot. Like I said, it's not critical, but you know, while you're at this stage and you've checked it out, why not do it? So what you can do, turn it off, turn it on, and it always returns to the closed position. Huh. I didn't get that one right. After all that. Oh well. You know what? I'm going to leave it. It's close enough as far as I'm concerned. But I wanted to show you how to do that.